Okay, here's a video. Some people asked some questions about sections R4 in doing factoring. First one is about grouping by factoring. So if I want to factor this expression, I see that there's four terms. And if there's four terms, often you'll be factoring by grouping. And when we factor by grouping, basically what we do is we take the first two terms, group them, take the second two terms and group them. And then I forget that these ones over here exist. And here I look for a common factor between these two. So the common factor here, there's not a number that's common, but they both could be divided by an x squared. So I'll take an x squared out of each one of those. Now you don't need to do this part that I'm going to do right here, but sometimes it helps some people. When you factor out an x cubed, really what you're doing is dividing each term by x squared. I think I said x cubed, but x squared. So if you factor out an x squared, divide each term by x squared. So in this case here, when you divide those, you'd come up with 3x. When you divide these two, anything divided by itself is equal to 1. So this first one I factored by grouping, I got that. Now I need to do the same thing with the second one. So I'll bring that back out and I look for something that's common between these two, or something that I can divide evenly into both. They both don't have a letter, so it has to be the number. It looks like 6 is something that I can divide evenly into both. And since this is positive, I'm going to divide both by a positive 6. Again, I'll do that intermediate step where you take the 18x and you take the 6 and you divide them both by the largest thing you can divide into them. So 6 and 18 is 3, so it'll be 3x. 6 divided by 6 is equal to 1. Now it's at this step where, I don't know if it's magic, but this is the part when you're grouping by factoring. If when you factor what you're left with is exactly the same, then you can go to a next step. If these two aren't exactly the same, you're done. They are the same though, so I can factor a 3x minus 1 out of this term and out of this term. If I take it out of this term, then I'm left with an x squared, just that part. If I take the 3x minus 1 out of this term, I'm left with a plus 6. So this would be the complete factorization of that expression there. Let's try another one. This one's not the group factoring, but this is one where you need to use the AC method to divide. I actually worked out the numbers before I started the video, so I didn't have to guess a ton. AC method says take this number and multiply it by that. So 6 times 28, I think, gives you 168. Then what you do is you look for two numbers that multiply to 168. So they have to multiply to 168, and they have to add to a negative 29. Add to a negative 29. Okay, so when you do that, I found that these two numbers work. So you'll take these, oh no, these two numbers actually aren't correct, because this times this gives me that, but when I add them, it doesn't give me a negative 29. So they both have to be negative. So this times this would be positive 168, this plus this would be negative 29. So then what I do is I replace this negative 29ab with this. So it'd be negative 21ab, and you just use whatever letters are with that, and a negative 8ab, okay, plus 28b squared. Now, what I'll do is I'll take and I'll group factor, just like we did in that last video. So I'm going to take these two group factor, these two group factor, and hopefully when I do that, I get the exact same thing out at the end. Okay, so out of here, I think I can take a 3, and I think I can take an a. So if I take this and divide it by 3a, I get 2a. If I take this and divide it by 3a, I think I get 7b. So I'm hoping I get the same thing over here. Okay, now this is a negative, so I'm going to have to divide a negative out. Looks like I can take a 2 will go, 8 won't, oh 4. I can divide both of these by 4. So I'm going to divide both of them by a negative 4, Looks like I can take a b out as well. So I'll divide this by negative 4b. That'll give me a positive 2a. Things are looking good. Divide this by negative 4. It'll be a negative 7b. Notice now this and this are identical. I can proceed with group factoring. So I factor that thing that's the same out the front and then write down what I'm left with. 3a minus 4b. Okay, the last question that somebody asked me is this one, and it's a sum of cubes. The instructions are to factor, so I need to factor this. So if I can identify that it's a sum of cubes, like 8 is the same thing as 2 cubed, and so both of those are 2 cubes, so it is a sum of cubes, then I use one of these rules that they have in the book to help me factor that. Now, first I need to figure out what is A and what is B, then I can just plug them in there. So 8 I said was 2 cubed, so 2 cubed times t cubed, plus 8 is 2 cubed. Now since both of these are cubes, I can get those together and just write it like this. 2t cubed plus 2 cubed. So A then, let me use a different color. A is 2t and B is going to be 2. So now what I do is I take, if I know that A and what B are, then I just plug them in up here and follow this format. So to factor this, it'll be, okay, A plus B. A is 2t, so I put a 2t here, plus B is 2. Okay? And maybe it's not a bad idea, maybe off to the side, to write A is 2t and B is 2, just so you can refer back to them. Okay, now I have to go A squared, so 2t squared, let me figure out what that is. 2t squared, I'd have to square both of those, so that'll be 4t squared. Alright, so this A squared is 4t squared, a minus, and then A times B. Okay, here's A times B, that'll just be 4t. And then plus, and then B squared. Okay, B is 2, 2 squared is 4. Done. So that there is the factorization of this one. Now one thing that you might have wondered about right at the start, and we could continue with this one because notice there's a common factor for all of those, and it might be worthwhile to do that because this one's really not completely factored because I could take out a common factor. I didn't take a common factor out of this to begin with, so maybe I should have done that because they each have an 8 in them, so it'd be 8 and then t cubed plus 1. Then it might make my format up there just a bit easier. Let me bring this down here somewhere. So if I factor out an 8 out of that, then my A becomes t and my B becomes 1. That'll be pretty good. So I need to have the 8 out there, and now I'm going to start right up here. So A is a t plus B, that's 1. A squared, so that'll be t squared, will be t squared, minus A times B, t times 1 is just t, plus B squared. B is 1, so 1 squared is just 1. So that's plus 1. So this would be the proper way to factor that one that I had at the start. Notice that this one, I'm just going to maybe go up on this one for lack of space. I could get the exact same thing as I have down there. If I factor a 2 out of this, I'd have 2 times t plus 1. You see the t plus 1 down there? Here, they each have a 4 in it, so I could really factor a 4 out, and it would be t squared minus t plus 1. And then if I take the 2 times the 4, I get 8 times the other stuff is exactly what I had down below. So multiple ways that I could get to that. the key thing is to use this template to help you factor a sum of cubes or a difference of cubes. Okay, hopefully that helps you with those questions.